Hi, welcome to my channel Mathematics Made Easy by Mary MJ. Today I am discussing class 11, chapter 13, limits and derivatives. We are continuing the chapter. Last video we discussed exercise 13.1 up to 8th question. So we are continuing now with the 9th question. We are finding out the limits. So next one is evaluate limit x tends to 0 ax plus b divided by cx plus 1. Okay, so how to apply limit here? So first thing is that we have to apply what is the value of what is given here. X is tending to 0. So that value we have to give for x here. That is the first thing. And check whether it is in the 0 by 0 form or a normal form or whatever it is. So if I am giving the value for x, so what happens? A into 0 plus b divided by c into 0 plus 1, and that is equal to b by 1, or that is b. So that is directly we can give the value for x and get the answer. So nothing is there to do in that question. Next one, limit z tends to 1, z raised to 1 by 3 minus 1 divided by z raised to 1 by 6 minus 1. So this we have seen somewhat like this way, one standard result, limit x tends to a, x raised to n minus a raised to n by x minus a. So we can convert this into this type of form. How can we convert this? Now it is limit z tends to 1. So in order to apply limit for such a type of problem, we have to convert into this standard form. So that is x raised to n minus a raised to n by x minus a. So here we can write it as z raised to 1 by 3 minus 1 raised to 1 by 3. 1 raised to 1 by 3 means 1 raised to any number is 1 itself divided by. So if z raised to 1 by 3 minus 1 raised to 1 by 3, now check here, x raised to n minus a raised to n, then denominator should be x minus a. It is x raised to n minus a raised to n by x minus a. So same form we can make it here. How can we make it here? If the denominator is z minus 1, then we can apply the limit for this. No, so it is in the standard form as this one. But here denominator is not z minus 1. So what I am doing is numerator and denominator I am dividing by z minus 1 to bring it to the standard form. So divided by. So now the numerator I am writing as like this. Now denominator divided by z raised to 1 by 6 minus 1 raised to 1 by 6, again divided by z minus 1. So that is what we are doing here. In the numerator and denominator we divided by z minus 1. So then if we are dividing the numerator and denominator, then there is no problem, right? So now we can apply the limits. The standard result, limit x tends to a, x raised to n minus a raised to n by x minus a is equal to n a raised to n minus 1. Same way in the numerator, if it is limit x tends to a, numerate f of x by g of x, we can apply the limit separately in the numerator and denominator. So here also we can apply the limit in the numerator and in the denominator separately. So here applying the limit, n a raised to n minus 1, n means it is 1 by 3 here, a is 1, so 1 raised to anything is 1 itself, divided by here n means it is 1 by 6 into a raised to n minus 1 means 1 raised to 1 by 6 minus 1. So no need of writing that because 1 raised to any number is 1, and this can be written as 1 by 3 into taking the reciprocal 6 by 1, which is equal to 2. So limit tends is z tends to 1, z raised to 1 by 3 minus 1 by z raised to 1 by 6 minus 1 is equal to 2. Okay. Now question number 11. Limit x tends to 1, ax square plus bx plus c divided by cx square plus bx plus a, where a plus b plus c is not equal to 0. Here directly we can give the value and check what happens for this. So if I am giving x equal to 1 over here, we are getting it as a into 1 square plus b into 1 plus c divided by c into 1 square plus b into 1 plus a. That's equal to a plus b plus c divided by a plus b, it is c plus b plus a, or we can write it as a plus b plus c, and since both the numerator and denominator are same, the answer is 1. Now question number 12. Limit x tends to minus 2, 1 by x plus 1 by 2 divided by x plus 2. So first we can directly check the answer whether what we are getting here. See, if I am putting x equal to minus 2 here, what we are getting? 1 by minus 2 plus 1 by 2 divided by minus 2 plus 2. See the numerator, minus 1 by 2 plus 1 by 2 is 0, minus 2 plus 2 is 0, so it is in the 0 by 0 form. So either we have to factorize or do any method we have to go for. So this is limit x tends to minus 2. Now I am cross multiplying this, that is 2 fraction addition. So 2 plus x divided by 2x whole divided by x plus 2, and that is equal to limit x tends to minus 2, 2 plus x and x plus 2 are same, 2 plus x by 2x, then x plus 2 by 1. If you are taking the reciprocal, 1 by x plus 2. Now the numerator and denominator consist of x plus 2. If you are cancelling that and applying the limit, first we can cancel these two, and what you are getting? 1 by 2x, applying the limit 1 by 2 into minus 2, which is equal to minus 1 by 4. Okay, next one. Question number 13. Limit x tends to 0 sin ax by bx. In the last video we discussed some of the trigonometric results, limits, applying limits for trigonometric results, that is sin x. If you are applying limit sin x by x, limit x tends to 0 sin x by x, we have learned it as equal to 1. Very important result. So this we can use over here, but here it is sin ax. So we can see here, if it is sin x, then denominator should be same. Sin x means denominator should be x. If sin 2x, then denominator should be 2x. Then only that limit will be equal to 1. Same way here sin ax. If sin ax, then denominator should be ax itself. So what we have to do here? We can write this as limit x tends to 0, then sin ax is there in the numerator, denominator also, if that a comes, then only we can apply the limit. So I am putting an a here, already bx is there. So first let it be the same thing in the question, we will write here, that is bx. Then numerator and denominator I am multiplying an a. Now what happens? This can be written as limit x tends to 0, just a rearrangement, sin ax by This A I am writing this side, B I am writing this side. So AX, and this B taking to this side, it is A by B. Now we know that limit x tends to 0, sin x by x is equal to 1. So here what is the coefficient? Coefficient is 1 here. No, same should be written here. That is, here 1x means here also 1x. Here Ax means here Ax tends to 0. Okay. So limit Ax tends to 0, sin Ax by Ax is 1 into A by B. So the answer is A by B itself. So how to apply the limit for trigonometric results? You have to go. You have to study this. This result is very important. Limit x tends to 0, sin x by x is equal to 1. Same way, limit Ax tends to 0, sin Ax by Ax is also equal to 1. So accordingly, that is, if I am giving the values for A as 2, 3, 4, 5, etc., this trigonometric result, the limit of this trigonometric result is same as that of 1. Now, next one, question number 14. Limit x tends to 0, sin Ax by sin Bx. So we know that in order to apply the limit, sin Ax denominator should be Ax. So we'll just write that limit x tends to 0. Here sin Ax, denominator should be Ax. Since I have divided an Ax here, we have to cancel out that by multiplying Ax. Then into, here denominator is sin Bx, that is 1 by sin Bx, that is in the denominator. So in order to apply result here, we have to divide by Bx and cancel that by multiplying by Bx. So now we can apply the limit. Applying the limit Ax tends to 0. If it is sin Ax, here also it should, we have to change it. Sin Ax by Ax into this Ax and Bx, we can write it at last. Then here 1 by limit Bx tends to 0, sin Bx by Bx, then into Ax by Bx. Now apply limit for each terms. So first part, if you are applying limit, we know it is 1. If you are applying limit over here, it is also 1. So 1 into 1 into this x can be cancelled from numerator and denominator. Remaining, we are getting it as A by B, and the answer is A by B. Now next question. So last question we were doing 14th one, now 15th question. Limit x tends to pi, sine of pi minus x divided by pi into pi minus x. So here if I am giving the value of pi here, again we are getting in the 0 by 0 form, because if I am putting x as pi, pi minus pi is 0, sine 0 is 0, same way denominator also 0. So we have to go for any of the method which we have learned. So I am going for substitution, that is I am giving here pi minus x, we can give it as y, some value. Pi minus x we are giving it as y, and if x, so at the same time if I am changing this side also should be changed. So here x is tending to pi, since I am changing everything in terms of y, this also should be changed, the limit also should be changed in terms of y. So how can we change in terms of y? We can give the value of x as pi in this result. So pi minus pi is 0, so y equal to 0. So the limit we can change it as, if x tends to pi, then y tends to 0. Then what happens to the limit? Limit y tends to 0 sin y divided by pi into y. There we know that pi is a constant. That pi we can take it out, that is 1 by pi out. Limit y tends to 0 sin y divided by y. And what is that? Answer is, what will be the answer? This part will be 1. So the answer is 1 by pi. Now next one is question number 16. Limit x tends to 0 cos x divided by pi minus x. If we are giving the value for x as 0, what happens here? It is cos 0 divided by pi minus 0. Cos 0, as you all know, that is 1 divided by pi. So the answer is 1 by pi. Question number 17. Limit x tends to 0 cos 2x minus 1 divided by cos x minus 1. So here if I am giving x equal to 0, what you will get? Cos 0, that is 1, 1 minus 1 is 0 divided by 0. So 0 by 0 form. So we have to simplify this result. How can you write this? Limit x tends to 0. Instead of cos 2x minus 1, we can write it as 1 minus cos 2x. Because 1 minus sign taking out, denominator also I am changing it as 1 minus cos x. Now that is equal to limit x tends to 0. What is 1 minus cos 2x? 1 minus cos 2x is 2 sin square x, identity from trigonometry, divided by, so what will be 1 minus cos x? It is 2 sin square x by 2. So 1 minus cos 2x is 2 sin square x. So 1 minus cos x is 2 sin square x by 2. And that is equal to limit x tends to 0. So instead of sin x, what is sin x? Sin 2x we know it is 2 sin x into cos x. So what will be sin x? It is 2 sin x by 2 into cos x by 2. So here 2 getting cancelled. Remaining limit x tends to 0. Instead of sin x, we can write it as 2 sin x by 2 into cos x by 2 whole square, whole divided by sin square x by 2. That is equal to, so now squaring the numerator, we can write here limit x tends to 0, 4 sin square x by 2 cos square x by 2 divided by sin square x by 2. Sin square x by 2 will get cancelled. Remaining, we can apply the result for x, that x tends to 0 here. So cos 0 is 1, so the answer is 4. Okay. Now next one, question number 18. Limit x tends to 0, ax plus x cos x divided by b sin x. So how can we apply limit? So for that we have to separate it. That is, this can be written as limit x tends to 0, ax by b sin x plus x cos x by b sin x. Now we can apply the limit for each term. That is, limit x tends to 0, ax by b sin x plus limit x tends to 0, x cos x by b sin x. Now that is equal to limit x tends to 0. Here we can see that this a by b is a constant, that we can take it out, remaining x by sin x, or it is 1 by sin x by x, because this x, if you are taking the reciprocal, we can write it in the numerator, the same. Then plus, here b is a constant, that we can take it out, 1 by b limit x tends to 0, here cos x into 1 by sin x by x. That is, if this x can be written in the denominator of sin x, because if you are taking the reciprocal, it comes in the numerator itself. Now we can apply the limit. Sin x by x, limit x tends to 0, sin x by x is 1, so a by b, then plus 1 by b into, here this is 1, cos 0 is 1, so into 1, and the answer is a plus 1 by b. Now next one, question number 19. Limit x tends to 0, x into sec x. So this is equal to limit x tends to 0, x into 1 by cos x, and that is equal to limit applying cos 0 is 1, x tends to 0 means 0, so that is 0 by 1, which is equal to 0. So there is nothing to write there. Then question number 20th one, limit x tends to 0, sin ax plus bx divided by ax plus sin bx. So how to apply limit here? We have to apply limit separately. That is, here ax is there. So if it is sin ax, then denominator of that should be ax. Same way here sin bx is there, so denominator of sin bx should be bx. So for that, what we have to do is limit x tends to 0. First I am dividing sin ax by ax. But if I am dividing by ax, that should be cancelled by multiplying an ax. Then plus bx divided by ax is there as such, plus sin bx. In order to apply limit, denominator should be bx into bx. Now separately we can apply the limit. Limit x tends to 0. If I am applying limit over here, it should be ax tends to 0, sin ax by ax into ax, then plus bx, then divided by, here also limit should be written, limit x tends to 0 bx, then whole divided by limit x tends to 0 ax plus limit bx tends to 0 sin bx by bx into bx. So each term we are giving limit. Then sin ax by ax is 1. Same way, so this is 1. Then this also is 1. So remaining what we are getting, here it is ax. So there also limit is there. Limit x tends to 0 ax plus limit x tends to 0 bx. Together I am writing divided by denominator also limit x tends to 0 ax plus bx, and that is equal to, x is common in all the terms, that we can take it out, remaining a plus b divided by x into a plus b, then x getting cancelled, we are getting the answer as 1. Now next one, question number 21. Limit x tends to 0 cosec x minus cot x. That's equal to limit x tends to 0 1 by sin x minus cot x can be written as cos x by sin x. And that is equal to limit x tends to 0 1 minus cos x divided by sin x. What is 1 minus cos x? It is 2 sin square x by 2 divided by sin x can be written as 2 sin x by 2 cos x by 2 because sin 2x is 2 sin x cos x. So here 2 sin x by 2 into cos x by 2. Now 2 getting cancelled, 1 sin x by 2 will get cancelled, remaining what we are getting, limit x tends to 0 tan x by 2. And if you are giving x tends to 0 here, tan 0, what is the, how to apply for tan x by 2? How will you write the answer for tan x by 2? That is, if x tends to 0, tan x by 2 is 0 itself. Okay. Now next one, question number 22. Limit x tends to pi by 2 tan 2x by x minus pi by 2. So if I am giving the value for x as pi by 2, 2 into pi by 2 means tan pi is 0, denominator also 0, so it is in the 0 by 0 form. So I am giving here substitution, that is we can give substitution as x minus pi by 2, here it is x minus pi by 2, or we will give it as x minus pi by 2, let us give it as y. And if x tends to 0, that is, if instead of x, if I am giving pi by 2, what happens to y? Y tends to 0. So the limit I changed. So limit, instead of x tends to pi by 2, y tends to 0, tan 2 into, instead of x what we have to give, pi by 2 plus y divided by y, because this minus pi by 2 taking to the other side, it becomes plus, and that is equal to limit y tends to 0 tan, this 2 we can multiply inside, we are getting pi plus 2y divided by y, and that is limit y tends to 0. What is tan pi plus theta? Tan pi plus theta is tan theta. So tan pi plus 2y is tan 2y divided by y. Again, in order to apply the result, apply the limit y tends to 0. Same way as sine, we have to use here tan also. So tan 2y divided by, here only y is there, we can write the 2y into 2. So this take the value as 1. So 1 into 2, the answer is 2. So these many questions are all same, how to apply the limit either by substitution or by factorization method. So again 23rd question onwards, we are having a different condition there, that is left x less than 0, x greater than 0. So the limit applying also will be a slight difference will be there, that we will discuss in the next video. Thank you for watching my video. Those who haven't subscribed, please like, share and subscribe, and also click on the bell icon for more updates and notifications. Bye.